For this problem, we're going to calculate the difference quotient for a radical, which presents its own challenges. So we have f of x equals the square root of x plus 6. And so we're doing f of 2 minus negative 2 plus h, minus f of negative 2 all over h. And so let's just look at it. What is our f of negative 2 plus h? That means that this negative 2 plus h will go in place of the x there. So that's going to be the square root of negative 2 plus h plus 6, which is the square root of h plus 4. Then f of negative 2 is going to be the square root of, that negative 2 goes in place of the x, negative 2 plus 6, which is the square root of 4. And I can't help call that 2. We could leave it as a square root of 4, and you'll see why you may want to do that. Maybe you don't. But when we look at the difference quotient, we have f of negative 2 plus h minus f of negative 2 all over h. And I'm going to multiply that by, and this is the part that I think, well, before I multiply it, let's write what that is. That's the square root of h plus 4 minus 2 all over h. Okay, so this, I got a little ahead of myself. We might want to we're going to have to multiply, and this is where, if you didn't have a strong footing in radical equations or simplifying radical expressions, this is where it can get difficult. I know this is something I cover in my Math 126 class, which it's and some people question why, and this is exactly why. So I'll multiply here by the square root of h plus 4 plus 2, the conjugate of that term, over the square root of h plus 4 plus 2. So multiplying by 1, but in the numerator it's a sum and difference. So we end up, and let me just kind of give you a little side reference here. Just recall that a minus b times a plus b is a squared minus b squared. So it has the property of squaring out those radicals. Okay, so we have, so square root of h plus 4 times square root of h plus 4 is just h plus 4. So it's that first term squared minus the second term squared. The second term is, it's 2 times 2, so we get a 4 all over h times, I can leave this factored, the square root of h plus 4 plus 2. Now, notice in the numerator, these 4's are going to subtract out. So we have h over h times the square root of h plus 4 plus 2. So we can divide these h's out. And what we have left is 1 over the square root of h plus 4 plus 2. Now we're going to look at different values of h. What if h is 0.1? What if h is 0.01? And we're looking at, and then we go negative 0.1 and negative 0.01. So we're looking on either side of this negative 2, essentially. And we're trying to see what is happening as we get to negative 2. So let's see. We need a calculator for this part. And we're just going to put it in. That's what I like about having a TI 83 or 84, something like that, is I can put this in one time, 1 divided by, I could do a couple things with this. So I'm just going to put it in here, 1 divided by, parentheses, the square root of, I'm going to do a variable, the variable that comes up is x plus 4, and then get out of the square root, and then plus 2, and then parentheses. Actually, I forgot, I'm not going to call it x, I'm going to call it 0.1. And I get that 0.248 0.248456713. So mine actually cuts off here, but yeah, I get that 0.248456713. I personally think going 4 places is probably sufficient. Then I can bring that last thing up and then change that 0.1 to a 0.01. Hit insert 0, and I got 0.249843945. They obviously go further than that. And then I can come back up and take that and put in an insert, hit insert, and I can put in a negative, and I get 0.25015644456. And then I can do the same thing. I can come back up and bring that last one. You can't see what I'm doing. I'm just describing. You can go up and then modify what you had in the last, or you can just retype the whole thing, whatever. And put a negative in there, and 0.25158233419. So mine rounded off after this, but this has more digits, obviously. So if someone told you that the derivative, the slope of the tangent line of f of x equals 2 was 1 over n for some integer, what would n be? So just look at where this is going in both directions. On one side we're less than 0.25, the other side we're bigger than 0.25, so it looks like it's 0.25, which is 1 over 4. So if they're saying it's 1 over n, n must be 4. That's how they get that. Okay, hope that helps.